Welcome to the demo part of our webinar for data lakehouses and IBM Cloud teaming up with Dremio. The first part of this demo, I will be showing you how you can use these different pillars of our data engine offering in the IBM Cloud for data ingestion, data transformation, batch query, and also using our built-in Hive Metastore. So I start by showing you a way to ingest data. So this is the user experience, the web console of the data engine service in IBM Cloud. And you basically have here a field where you can enter and run SQL statements and preview the results here. But I'm starting to show you how you can ingest data. And for that, we are looking at the streaming feature. So you can look at the list of jobs here. When I go to the streaming jobs, you see there's a job running here, a streaming job. And that's my ingestion job that I'm using for demo. And actually this job, if you look at the date here, runs for almost a year already now, right, without problems. And when we look what this job does here, you can see it actually is expressed as if in the form of an SQL statement. And so you can quickly get the semantics here by seeing I want to select everything that comes in from this source. And this source here is an instance ID of an event streams instance. Event streams is the managed Kafka service in IBM Cloud. In that event streams instance, I want to select everything from that topic. I'm telling my system that the message format is JSON. And what should happen with this data, it should be emitted to object storage, cloud object storage in this region, into this bucket, into this folder here. And the target should be stored as Parquet. So that's basically how the job is expressed. It says this is a stream data landing job that runs now continuously, right? As you can see here, almost a year now in my case. So basically it's a job that continuously shuffles data from this Kafka service here, event streams, into this cloud object storage bucket in the form of Parquet data. You can basically, you do not necessarily submit a job here. Basically, you go, when you set up that job, you go to the interface of the event stream service. So when I click here, I'm launching the web console of the event stream service. So this is, as I said, event streams. It's managed Kafka and IBM Cloud. You can see the list of topics here. And this topic here is exactly where this job is currently running, right? And if you want to set up a new one, you will basically just go through this wizard here, where you say, I'm specifying which cloud object storage target instance, in this instance, which bucket name I want, which data engine instance I would like to use to run this streaming job, and then also specify things like the prefix, the folder name, and so on, and some authentication information, what ID should be used, and so on. So that's how easy and quickly you can set up a streaming job. And when this is done, actually it just runs here. You see the status running here. And in the data engine perspective, it looks like this. Now, what this does actually, as I said, is shuffling data from this Kafka topic into this cloud object storage bucket. So let's look there. What's showing up in the target? And this is now our list, our object view in the cloud object storage dashboard. And as you can see, what is showing up here is just Parquet files, flat Parquet files. Every few minutes or even seconds, depending on the throughput of the volume of data, new Parquet files will show up with the message data that basically has come in to the topic. So this is something that means you can immediately analyze this data if you want to. It's immediately available for analytics. So if you go back to the data engine here, I can actually see in my list of tables that I have defined here, I have defined a table I call the JSON feed landing table that is defined on exactly this location here, right? So this object storage folder where these Parquet files are written. And you can see there's a schema that we have discovered basically from the Parquet files here, and that's the raw data that has been landed. Now, a first point of attack, if you want to make it a little bit easier to analyze, very often you may want to do some basic transformations on this data. So in our case here, I've created just a view. So it's just a logical transformation on top of this. So if I look at this view, I call the JSON feed view. You see, it's basically taking everything from this landing table and does some basic transformations, just column names, extracting some timestamps here, so data type transformations, or also flattening some nested structure here, so that it's basically more rectangular in the schema of this table, which makes it a little bit easier if you want to write SQLs on top of that. But that's really just the first point of attack, and in fact this is not what you want to use in long run to analyze your data, because what is going to happen is it continuously shows up new Parquet files in your folder, which is good for a day, but if that happens over weeks, or in my case a whole year, it will be thousands of these Parquet files with small, comparably small data. So that's a very typical pattern in practice, to then have a post-processing going on to compact this data into coarser grained chunks, and also to structure it by some keys that you may want to use to analyze this data. So if you want to analyze the data by filtering for time frames, you may want to partition it into some time, discrete time partitions. So, and if we look at what I've done here in this demo, there's another table, I call it streaming mart, which is on a different folder, still same bucket in my case, but a different folder here. And it has a lot of partitions. It has the same kind of columns that we already saw in this view, but it now has a lot of partitions. And if you look at the partitions here, these are partitions by date and hour. So we have actually per hour partitions over the course of this full year of data in my case here. Now let's look at how the data looks like. Right? If we go into this location here in the Cloud Object Storage, to the landing mart, you see there are folders, subfolders, right? This is the folder for the days, and inside the days we have folders for the hours, and inside the hours we have the actual Parquet file. Right? So this is how the data is structured here. These are real partitions, and now I have defined a table on top of that that automatically has recognized and discovered these folders as partitions. And this is what you're going to use as your data mart to really analyze this data. Now the question is, how did I get the data from this raw data location, landing location, to this data mart location? I'm also using data engine for that. So what I'm using is the capability to run ETL statements. So here's an example of such an ETL statement that will basically take data from my raw data view by the hour. So in this case, it will just take from this very specific hour and produce this very specific target folder. So this is one ETL statement that just needs to run in an automated fashion. That's exactly what I've done here in my case. I've automated to run those statements every few hours to see and figure out all of the data that has arrived since the last time it ran, and for each hour basically produce a new target folder. And after this job has run and has produced this new basically target folder with a single Parquet file, I'm now making this new folder available as a partition, and that's achieved with a simple DDL statement like this one. Right? So just all the table and add that new folder as a partition. And that's basically also just run in the automated fashion. Now, there are many different options how you can automate those statements. In my case here, this is just an example, but it's a very elegant one, is you can use another serverless feature in the cloud that has scheduling capabilities. And this is our code engine service. So I'm not going through code engine demo now, but this is just how it looks like in terms of the cloud console. So I have so-called projects, and I have in these projects jobs. So I have here, this is this compactor job that runs those DDL and ETL statements that I just showed to you. And then I have automated them with a schedule here, which is basically this periodic timer trigger here that just is basically a cron notation that you can specify. And that's how I completely automated all of this post-processing in a serverless fashion. So I don't have to run actively something like Airflow or Kubeflow, which of course you can, but you don't have to if you want to stay entirely serverless, and this is the option I just want to briefly call out. Now next, we want to see how can we consume this data, right? I have ingested it, I have prepared it, and added it continuously via this compaction into these partitions here. How can I consume it? So as I've shown to you, I have already prepared this data mart table here, streaming mart, with many partitions, right, for each hour and each day since last year, so thousands of partitions. For the sake of this demo, I've singled out basically just one day, so I've created another table that just goes to exactly one day folder here. Makes it easier for the demo purposes, right? So it's basically a specific subfolder of this mart location. So with just one partition for each hour. That's why 24 partitions here. So I can now query this table. Just click on query and it will generate a simple, basically select star, just limit 50, and it will give me a sneak preview into the data that has been landed. So I can also understand, for instance, what kind of values are there, what might be the semantics, the column schema, and so on. So here we see the result of that has been, so it's the preview of our data. But of course, typically I want to do some more real analytics, and a simple example here, I just want to basically get some aggregates. In my case here, I'm taking the humidity measurement and want to basically cluster it by device. That I have IoT device that I have captured in my real-time data stream here. And as you can see, this takes a few seconds, right? It's not basically extremely interactive necessarily, but it's actually completely ad hoc, completely serverless, completely available whenever you need it. So you see, I have basically, this is the aggregated information for the humidity for each device for that one day. It took a couple of seconds here to run, and basically also the serverless nature means we will only charge you for the data volume that has been scanned for that one execution. You will not have any cost to run anything here until you really run a SQL statement. And the SQL statement cost is derived from how much data it had to basically read. So that's how this whole data engine serverless business model works. It's only pay by the drink. But what is also now obvious here is, as I said, it runs for a few seconds. So data engine is really a great thing for background analytics, batch analytics, and of course all of the onboarding, which you typically also want to do, like the ingestion, the ETLs, in the background. This is not something that you want to do interactively. That's where data engine is great. It uses Apache Spark behind the scenes, so it also scales out. It can do these operations for gigabytes and terabytes of data. That's not a problem because it just automatically scales out. But it's not geared towards an interactive sub-second response time because of its serverless nature that is implemented on top of Spark. Next, I would like to show you how you can use this Hive Metastore feature, not just in combination, as we've just seen, with the built-in processing capabilities, but how can you use your own processing engines and environments with the metadata stored in Data Engine and use it as basically as a catalog service for your own big data runtimes. So for the purpose, I will pick in this case for my demo now the Data Fabric, which is the IBM portfolio for our data and analytics services. It includes things like machine learning and so on, but it also includes data science tool chains, like for instance a Jupyter Notebook integrated user experience. So I'm using that now together with the capability to run Spark, custom Spark runtimes behind these notebooks. So basically also I'm showing you now how you basically can go from the data engine as only the catalog service and then combine it with processing in something like the analytic engine with your custom Spark cluster. So here we are at the Cloud Pak for Data user experience. Cloud Pak for Data is the product that brings you these data fabric services that I've just mentioned. And I'm inside the Watson Studio, which is the Jupyter Notebook toolchain in Cloud Pak for Data. So I'm now in the Jupyter notebook in Watson Studio, and this is our standard demo notebook for Data Engine. I will see whether I can also just add it here to the webinar resources, so you can basically get it as a source file itself to load it into any of your own Jupyter environments or also into your own Watson Studio projects. So it's really, as I said, our standard notebook for all of the things that you can do with Python and with the notebook interface for Data Engine, but it also includes this section that I'm showing you now, which is how you use custom Spark with the Hive Metastore in Data Engine. If you're using your custom Spark runtimes, you may basically have to, or you should deploy some libraries from Data Engine. It makes it easier for you to configure a Spark environment or a Spark context that has the Hive Metastore configured from Data Engine. But if you're, for instance, using Watson Studio in the cloud here, this is actually also provisioned out of the box, so you don't have to go through these steps. So we go to this section here. The important thing, basically what you need is exactly this here. So you just say, okay, I'm getting a special Spark session builder here with Data Engine, and just giving us the API key that you use in order to talk to the Data Engine service to authenticate yourself. You can then basically use the session builder here in order to build a Spark context, which is just like any Spark context, just with the difference that it has configured the Hive Metastore of Data Engine as the catalog. And this cell is just for informational purposes, where we just print out this information so you basically can see what's happening under the hood. Basically the Metastore URI is configured to this thrift endpoint of the Data Engine service here in your case. I've set up here, if you run Notebook, you can also do it with a cell yourself, but I've set up already a table that I want to use now in the table catalog with my own Spark runtime that I'm using here. Python, I'm using Python with the Spark runtime in my Watson Studio service. Basically all what you do is really just standard Spark operations, Spark SQL in this case, where I'm selecting basically from this table that I've just configured. This table is defined in Data Engine, but all of the execution, the processing, the reading of the data, the SQL compilation, all of that is happening in your own Spark runtime, in this case here in Watson Studio Spark with the Spark runtime support. But it would work in this very much the same way with any other Spark cluster that you have set up yourself anywhere. So now we want to take a look at how you can set up Dremio in context and in combination with the Data Engine service in IBM Cloud. So we're talking about to deploy your own license of Dremio, be it a community edition or a commercial license of Dremio, into IBM Cloud, into our Kubernetes options, into our OpenShift or Kubernetes services that we have available in the cloud. So you should, the first thing is you need a Kubernetes cluster or an OpenShift cluster before you do that. And then you can use the rest of this procedure. If I take a look at our my account here, you can see that these are my Kubernetes clusters. I could create a new one here. I could also go and select an OpenShift cluster. But in my case, I've already run it. I have deployed it already. So it's a Kubernetes cluster that I have configured with a certain set of workers in my virtual private cloud environment. So it's in the VPC context, entirely isolated from all the rest in the public cloud. So in order to basically go there, we can go to this cluster here and see, okay, there's a couple of things deployed here, a couple of nodes. Before we look into these nodes, what Kubernetes or what pods are actually running there, let's briefly review again how to set it up. Actually, you're using Helm charts and using the Helm commands to deploy these Helm charts. Now, this is again something where we make it a little bit easy for you, because you can take these Helm charts here that we have customized for IBM Cloud as a starting point. Right, and you just basically take this repository here, if you like, to clone it, and you can then configure the size of your Dremio cluster in this Kubernetes environment in terms of the size of your worker and pods and so on, memory, cores, and so on. Just setting up the values here accordingly. Then you run the ham commands, and what you get then is this Dremio cluster inside, you get a set of Dremio cluster set up inside this Kubernetes cluster that we are looking at here. So I'm now taking a look here at the standard Kubernetes UI, which is should be familiar to you if you're familiar with Kubernetes. And as you can see, there are a couple of pods here: Dremio executors, Dremio master, some zookeepers, all standard. Basically, how you set up Dremio. Nothing basically spectacular or proprietary. And if we look here at the services, so those are the things that are externally available, basically externally connectable. You see, okay, I have this Dremio client service, which is basically giving me access to the Dremio UI. So I'm now clicking on one of those links here in order to get to the web UI of Dremio. And here we are. And the first thing that we need to do next, now that the Dremio cluster is running and working, I can access it, I need to connect it to Cloud Object Storage data. And the way to do this is just by the means of S3 compatible file storage. So here you can connect S3 file stores just by providing access key, secret key, and so on. The only difference for us now is this is running an IBM cloud with the IBM Cloud Object Storage, which is fully S3 compatible. So here we have an example of basically my data lake that I have configured. So you see I have some access key, secret key. The specialty now is here in the advanced options. I have added this specific endpoint where I'm overriding the standard Amazon endpoints, so that basically the whole communication goes against the IBM Cloud endpoints. That's all what you have to do. And then you can actually go to this data lake, right? Here's the Cloud Object Storage, the same bucket that we saw before in the data engine demo, where we see the landing data and the mart data where we have prepared these different folders that we see here. And inside those folders we have the subfolders for the hours, and inside there we have the Parquet files. So nothing spectacular, exactly the same data that we've seen before, just now accessing with Dremio. So I've also configured here some tables in Dremio, same one that I have in Data Engine. So for instance, if I'm going against this one here again, this one day worth of data, I can run a query, select start, it comes back in very short time, right? And I can also now run exactly the same analytic query that we saw in the demo before, where it ran a thing in a serverless fashion, right? Again, data engine entirely serverless. You don't need any Kubernetes to provision. It's available anytime, and you just pay for when you run a query. But it also means it's not basically that interactive. It ran, I think this query was 22 seconds in our demo. Now I'm running exactly the same data on exactly the same data for the same query. And it comes back in also less than a second here. Right? And this is basically possible because I have also configured, I mean, first of all, Dremio basically is much more geared towards interactivity, but you can also configure here things like so-called reflections. Right? That's what I have set up also here. Reflections where aggregations are pre-done by certain dimensions, certain measures. In my case, I needed this humidity measure. So this is how you also can speed up further Dremio processing. This is part of the secret sauce of interactivity of Dremio. Now finally, also what I briefly wanted to touch on is this ability to set up basically Dremio on top of Data Engine, which is possible via this connector here, right? So this is something that you need to set up yourself. This is not coming with the vanilla Dremio image. You need to deploy a custom connector, but you can find that connector in the Dremio Hub, which is here, right? Dremio Hub, where you can download this connector and deploy it into your Dremio image. So this is what I have done here in also this Dremio deployment. And where you see this is now, if you click here, external sources. So this is basically federated access to federated query engines, and Data Engine being one of those. So I could add new ones here, like Oracle and so on, but this is now here the Data Engine option that you can also set up. And in this case, it can just participate in a distributed federated query, which is another capability that Data Engine and Dremio can work together. This concludes the demo part for this webinar. Thank you again for attending the webinar. Thank you for your interest in this demo. And again, don't be shy of reaching out to Jason and me. We are really looking forward to your questions and your problems and your use cases. Thank you.